Welcome back. My name is Athena from Dreamforge Academy, and I will guide you through this lesson. Today somebody presses disconnect, reads the word disconnected, and closes the laptop. They connected that assistant a month ago. The token it holds stays valid for another 47 minutes, and every call it makes still returns 200. Nothing shows up in your logs because your code never asks whether that consent still exists. You wrote a button that deletes rows, and nothing in your app reads those rows. The fix is one indexed lookup on every call, and a test that replays the same request after disconnect. The client name on that screen is attacker-controlled. Dynamic client registration is anonymous, so a stranger posts any name they like, gets a client ID back, and sends your users a consent page in your own branding. You can't check that name, so say so in small type under the heading. This name was chosen by whoever is connecting, and nobody verified it. Show the real account name, and email the grant would act as. Let the tick boxes narrow the signed request and never widen it. And if someone unticks everything and presses allow, that's a refusal, not a token that permits nothing. Revoke is 3 deletes, and the order isn't a style choice. Access tokens first, then refresh tokens, then consent. Tokens go first because tokens are the things that still work, and a refresh token is a token printing machine. Make the consent delete your guard. If it removes 0 rows, return early. A double click becomes harmless, and one account can't revoke another's grant. Leave the shared registration alone unless 3 probes say nothing remains for it from anybody. Leaving them forever is wrong too. A stale registration is pinned to the scopes it asked for on day 1, so sweep daily, older than 7 days, created date not null. A self-contained token carries everything needed to verify it, offline with no database round trip. That's why your tool calls are fast, and it's exactly why disconnect does nothing. Verification has to re-ask the one question that can change between issue and use. Does the consent this token was issued under still exist? Every call. Not cached, not sampled, not writes only. One indexed lookup on user ID and client ID, selecting a single ID column so the database never leaves the index. And read the ASP claim, because on a real BetterAuth token that's where the client ID lives. Miss it and the lookup gets null, so every call returns 401 while your signature checks pass. Prove the revoke bytes because that's the only evidence that counts. Complete a connection and capture the access token. Make a real tool call and confirm 200. Press disconnect in your own interface, not in a database console. Don't restart the server and don't wait for expiry. Replay the identical request, same token, same headers, and read the status code. You want 200 before and 401 after. Still 200 means your verification is signature only. 200 until you restart the process means you're caching consent in module state, so your revoke works on your laptop and fails on a platform running several instances. The screen is where you ask. The button is where you promise. Both have to be true or neither is worth anything. Your assignment is a 1-page revoke proof, 4 measured lines and 1 test. A fresh token returns 200. Disconnect is pressed in the real interface. The identical, unexpired request returns 401, no restart, and no waiting. The consent rows for that user and client are 0. Then a rolled back test with 2 accounts on 1 shared client. A's revoke clears A, B's grant and tokens survive, and a second revoke by a changes nothing. Thank you for watching. Follow along using the course material and complete the lesson assignment. I will see you in the next lesson.